Hello friends, welcome to Shiksharthi. In this video, we'll be solving questions of exercise 5.2 on arithmetic progressions and series. So let's start. Now talking about question number 6. Now question number 6 says, check whether this particular number which is minus 150 is a term of the arithmetic progression which is 8, 11, 8, 5 and 2. So the very first thing that you need to do here is write down the nth term of this series. So which is nothing but 11 plus n minus 1. What is the common difference here? 8 minus 11, which is minus 3. So can I say this is nothing but 11 plus 3, which is a 14 minus 3n. Let me check whether the value that I have got for the nth term, is it correct or not. So substituting the value of n as 1, I get 14 minus 3 as the first term, then 14 minus 6 as the second term, then 14 minus 9 as the third term. Now they are interested in knowing whether this term belongs to this series or not. For this, you just need to put the value of an as minus 150 and then check it out. So can we say this is nothing but 3n is equal to 164? Now you know that the number of terms has to be a natural number because the number of terms is a count. You cannot get the value of n which is not a natural number. Okay, so but let us see, have we done it correctly? Yes. So here the value of n comes out to be 3 into 5 is 15, 15, 3 into 4, 12, 3 into 5 is 15, and then you get 14, 3 into 4 is 12, so the remainder is 2. So you are not getting n as a natural number, so this term does not belong to this series. Talking about question number 7. Almost a similar kind of a question wherein it says, almost a similar, find the 31st term of an arithmetic progression whose 11th term. So you are supposed to find out the 31st term whose 11th term. Okay, rather than writing it like this, it will be better if we just use the terminology, which is you are supposed to find out the 31st term. The 11th term of the series is given to you as 38. 16th term is given to you as 73. Okay, so if you recall, we discussed that any term, let's say kth term of an arithmetic series, these are the two terms of the same arithmetic series, is nothing but k minus r into d, right? Okay, now when I say that this is this, so what I can do is I can say a16 minus a11 is just like saying 16 minus 11, which is 5 into d. Now this value you can find it out from here. How much is this? 35. So we get the value of d from here as 7. Now you need to find out the 31st term. So 31st term minus any other term from here. Let's say you take the 31st term and the 11th term from here. This should be how much? This should be 31 minus 11 into the value of d which you have already got. So this comes out to be how much? 20 into 7 is 140. So from here you will say the 31st term is nothing but 140 plus this term which is 38. So you get the answer as 178 as the 31st term. Talking about question number 8. So question number 8 basically talks about an arithmetic progression consists of 50 terms. So the value of n is given to you as 50. What is the next piece of information given here? It says the third term is 12. So a3 is given to you as 12. Okay. And the last term is given to you as 106. You are supposed to find out the 29th term. The last term here is they are referring to an. Okay, no. They are referring to a50. Because the last term here, you have how many, what is the number of terms here? So the last term, so if you say that there are 5 terms, the last term would be 5th term. So if the number of terms is given to you as 50, in that case a50, they have given to you as 106. And they are asking you to find out what? They are asking you to find out the 29th term. So almost a similar question as we had done question number 7. Okay. Now A29 there are many ways of doing this, but we need to find this out. So how do we start? Let us say the 50th term minus the third term will be how much? 50 minus 3 into d, right? And then I need to find out the 29th term, which I can use it from here only. Okay, so now can I find out the value of d from here? How much is this? This is just like saying 106 minus 12 is equal to 47d. Therefore, the value of d comes out to be, how much does this come out to be? So 106 minus 6 is 100, minus further 6 is 94. So 94 divided by 47, you get the value of d as 2. The moment you get the value of d as 2, what you can do here is you can say that the 29th term minus the third term is just like saying 29 minus 3 into the common difference, which is 2. How much is 29 minus 3? 26 into 2 is 52. So you need to get the 29th term from here, which is 52 plus the third term, and the third term here is 12. So you get the answer as 64. Hope the answer is correct. Talking about question number 9. Now question number 9 basically asks you to do what? If the third and the ninth term, so third and the ninth term are given to you, and they are given to you as 4 and minus 8 respectively. That means this is a decreasing arithmetic series, because this term, the preceding term, I mean let's say the preceding terms or the terms which come before this term are greater than the terms which are coming thereafter. Which term of this AP is 0? So they are asking you to find out which term of this AP is equal to a 0. So you need to get the value of this from here. So can I use the same logic which I have been using elsewhere, which is A9 minus A3 is just like saying minus 8 minus 4, which is equal to how much? 9 minus 3 into the common difference. Okay. Now from here, can I say the common difference is how much? Minus 12 upon 6, which is equal to a minus 2. Right. So from here you got the value of d as minus 2, and you are interested in knowing which term of this series will be equal to a 0. Now on the inspection itself, you will come to know that any term which lies between the third term and the ninth term itself will be a term which will be equal to a 0. It cannot be before this, cannot be after this. So the term which you are supposed to find out will be a term which will fall between the third term and the ninth term. This is the amount of introspection that you need to do before you proceed. Okay, proceed from here. So now let's say A9 minus A4 should give me what? Should give me n minus 4 into d. And what is d here? Minus 2. And what is the value of an here? 0. So can I say now minus a4. So what is the value of a4? 4. So minus 4 is equal to n minus 4 into minus 2. Now the value of n minus 4 can be written as 2. So in that case the value of n comes out to be 6. So which term would be 0 here? 6. Which you can now, I mean if you want to really check your answer, you can say that the first term was 4, the next term is 2, the next term becomes 0. Okay. Now when you do this, you see that, oh, when the common difference was minus 2, how did I make a mistake here? So let's see what is the mistake that we have done here. So now the first term here was, is there any mistake that we have done here? Let's see that. Okay, so now this is not the first term, this is the third term. Then minus 2, you get a 2. Then minus 2, you get what? You get a 0. So what we did here was, we said that an minus, now this is not a4, this is a3. So this value comes out to be n minus 3, this comes out to be n minus 3. In that case we say this is n minus 3, and this comes out to be n comes out to be 5. So the value of n coming out to be 5 means what? This was my third term, this is my fourth term, and this is my fifth term, which will come out to be a 0. So which is the term that comes out to be a 0? The fifth term comes out to be the 0, because the value of n that we got here is how much? The value of n that we got here is a 5. Yeah, let's go ahead. So we have done till question number 9. Let's move on to question number 10. So in question number 10, they say that the 17th term of an AP exceeds the 10th term by 7. Okay. So can I say this is just like saying, so what is the value of D that you get from here? The value of D that you get from here is 1. Using which formula? Using the formula that we have been using in the earlier questions, which is AK minus AR is equal to K minus R into the common difference of the same series or of the same arithmetic progression. Find the common difference. You got the common difference as 1. Talking about question number 11. Okay, question number 11 talks about which term of the arithmetic progression, which is 3, 15, 70, 3, 15, 27 and 39. So which term of this series will be 132 more than the 54th term? 132 more than the 54th term. So which is just like saying an minus a54, using the same formula as we have used here, should be how much? N minus 54 into the common difference. Right? Now, what is the common difference of this? So it is just like saying 15 minus 3 or 27 minus whatever. So you'll be able to say that this is nothing but N minus 54 into 12. Right? And this difference you already have it as 132. So 132 divided by 12 is just like saying 11, which is the value of N minus 54. So what is the value? Therefore, what is the value of N? N should be equal to a 65. So the 65th term of this series is 132 more than the 54th term. Let's move on to question number 12. So question number 12 talks about two APs have the same common difference. The difference between their 100th terms is 100. What is the difference between their 1000th terms? Okay. Now there are two arithmetic progressions. So let us say AP1 and AP2. So let's say AP1, the first term is this, second term, third term. So in that case, the 100th term is what they are talking about, the difference between their 100th term. So the 100th term here would be A1 plus 99D would be the 100th term here, using the formula A plus N minus 1 into D. And in this AP, let's say the first term of this AP was A2. So here the 100th term would be A2 plus 99D. And what do they say? They say that the difference between this. Now when you're taking the difference here, either you'll take it as AP1 minus AP2, because the difference does not have a direction. The direction in the difference has to be decided by you. I repeat, if somebody asks you to infer the difference between A and B is 10, it does not mean that A minus B is equal to 10. It means either A minus B is equal to 10 or B minus A is equal to a 10. So I'm using the same logic here. So logic has to be applied in maths, otherwise it becomes difficult for you to talk about all possible cases and henceforth proceed with those cases. Okay, so you can use any of these. So let's say if I use this, I'll be able to say A1 minus A2, because 99D and 99D they get cancelled out, is equal to 100. Now when I talk about their 100th term, the 100th term here will be what? A1 plus if I talk about the 1000th term, the 1000th term here would be A1 plus 999D and A2 plus 999D. Then their difference would be what? The difference would be the same as A1 minus A2 only. What I'm trying to say here is, so if you are finding out the 100th term, the 1000th term of the first AP, that will be A1 plus 999D. And when you are talking about the 1000th term of the second AP, will be how much? A2 plus 999D, wherein you know that common difference is the same in both the series. Now when you are subtracting, since we are using this, or we could have used this, does not make much of a difference. We'll see that it does not make much of a difference, because in this case you are saying A1 minus A2, or in the next case you are saying A2 minus A1. Now when I subtract, from the first, if I subtract the second, so I'll get the difference here as A1 minus A2, which remains the same as 100 only. Right?